Amazon S3 now supports conditional requests. You can use conditional requests to specify preconditions to your S3 operation. If the preconditions is not met, it will result in the S3 operations failing. There is no additional charge for conditional requests, and you're only charged the existing rates for the applicable requests, including the failed operations. In this video, let's explore both conditional reads and conditional writes in Amazon S3 and how to use them when building .NET applications. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Let's switch over to Rider, where I have an existing ASP.NET Core API application set up. So in here, the program.cs, I have a new post method which is used to upload a file to Amazon S3. Now in this case, it simply receives a file from the request, reads it from the stream and uploads it as a new file to Amazon S3. I'm using a bucket which is already existing in my Amazon S3 account. So if I switch over to my console and navigate to buckets, you can see that this has the bucket user services large messages. So any files we upload using this endpoint is going to end up in that specific bucket. So let's run this and see this application in action. So since it's ASP.NET Core default, it launches the Swagger UI, which I can use to upload the file. So let's say try it out and let's choose a file and select the file to upload. In this case, I have a file hello S3, which simply has the text hello S3. So let's choose this and execute this to upload this file. So this upload has been successful. So if I come back and refresh on this S3 bucket, you can see that file exists in here. Now, if I go back to the Swagger UI and let's say I updated this again, and if I update this file to upload once more, this is going to overwrite that existing file. Now, this might be okay depending on your use case. Now, if these are concurrent requests from different users, then you might end up overwriting one of these files, which might not be something that you intend to do. In these cases, you can use conditional writes in Amazon S3. With conditional writes, you specify an additional header on your request and you can prevent overwrites of existing data by validating that there is no existing object with the same key name already in your bucket. So conditional writes will check for the existence of the object during the write operation. If an identical key name is found, then the write operation will fail on the bucket. The write will succeed only if the key does not exist. The put object and the complete multi-part upload are the two APIs that now supports conditional writes. So you can specify the if none match header on these API endpoints. The value that you need to specify for the header is just an asterisk. So let's see this in action. So if I come back to our ASP.NET Core application, you can add a new property to the put object request and specify the if none match property. Now this takes in the value of a string and let's specify this as an asterisk. Now in this case, if I run this application again and try to upload the exact same file name, this is going to fail. So let's expand this again, try it out, choose the same file hello S3 and let's say execute. Now in this case, since we have specified the if none match and since a similar file exists in our S3 bucket, this is going to return an error. So you can see at least one of the preconditions you specified did not hold. This means that the file already exists and it threw an exception when trying to write. Now, if I was to choose a completely different file, which does not exist in Amazon S3, this is going to upload successfully. So you can see the upload request is successful. And if I come back to my bucket and refresh this, you can see the new file that I just uploaded. Any subsequent uploads to the same file name will throw an exception. So if I choose this file again and click upload, it's going to fail with the same error that the preconditions did not hold. With this conditional write, it allows us to avoid overwriting of existing files and also avoid concurrent requests overwriting the same file. Now this is going to work only for new files that is getting written and does not work for existing files that is getting updated. Now if your use case is actually involving to update existing files, then the conditional writes might not be for you. In this case, it's best to enable version history on S3 so you can at least see what the different versions on S3 are to see the different updates that's happening on your file. If you want to learn more about version history, check out the video linked here and also in the descriptions below. The conditional writes does work on a versioned bucket as well. Now in this case, if you specify the if none match header, the write request will succeed only if the object doesn't exist or if it is a delete marker that exists for that specific key. So if the file is already deleted or it does not exist, in these both cases, the write operation will succeed. For anything else, that is going to fail, like just we saw in this example. The conditional request is also supported on multi-part uploads, which means if you're trying to upload an object in multiple parts, the final write operation, which confirms the upload, is going to check if the key exists or not. Now, in this scenario, you can see that the client 1 is trying to create a multi-part upload using 3 update calls, and there is client 2 which writes a new object with the same key. In this case, the multi-part call, which tries to confirm the file, will be failing because the object is already existing by client 2. Similarly, if in a multi-part request, if the object is deleted, in this case also this will fail. However, this will fail with a different error which says 409 conflict response. This is because the file is already deleted once it has been started writing. Now, I'll leave this to you to work out on the examples. However, if you want me to demo some of these use cases, let me know in the comments below. S3 also supports conditional operations for read operations. So you can use conditional reads on get, head, and copy requests to only return an object based on its metadata. Now, when you upload an object to S3, it creates controlled metadata that can be modified only by S3. Now, e-tags and last modifieds are example of these metadata. Now, the conditional operations uses these metadata to perform reads on a conditional basis. So you can return an object based on an object's e-tag or the modified date. So you can specify either a e-tag value or a modified date and return the object only if it's modified or if it is not modified. So this supports a few different combinations. So you can see on the get object, it supports a if match, which returns the object only if the e-tag matches the one that you provide. Or you can also use if modified since header. This will return the object only if it has been modified since the specific time that is specified. You also have the negated version of these, which is if none match and if unmodified since. So if none match means it returns the object only if the e-tag does not match the one that is provided. Similarly, with the if unmodified since. Let's see an example of this. So let's switch back to our ASP.NET Core application. Let's add in a new get endpoint inside our API endpoint. So let me copy and paste a get endpoint code. So this simply adds a get file endpoint, which takes in the file name and it uses the S3 client to download the file based on that file name. Now, in this specific case, we don't have any specific e-tag or last modified specified. So let's add in a new property. Let's call this as e-tag and let's use this in our get object request. So in the request, we can specify the e-tag to match or e-tag to not match. So let's use the e-tag to match property and let's specify the e-tag. So this e-tag should explicitly match on this request for that object to be returned. So let's stop this and run this again. Let's click get file and let's say try it out. In this case, let's specify the file name as file.pdf and let's specify a random e-tag value. In this case, since the e-tag value does not match, it throws an error which says at least one of the preconditions you specified did not hold because the e-tag on this file is something different. So if I switch over to S3, let's navigate to file.pdf. Let's copy the e-tag value from here and use that inside our request. Let's click execute again, and this time the file is successfully returned in our request. Now, similarly to specifying the value that exactly matches, you can also specify the negated header. In this case, you would specify e-tag to not match, and in this case, it would just do the opposite of what just happened. So if I specify the e-tag value, which is exactly the same like before, in this case, it throws an exception saying error code not modified and HTTP status code not modified. This is because the file is not modified based on the preconditions and it does not return back the specific file. Now, in this case, if I specify a value that does not match the e-tag, In this case, this successfully responds with the file details because the E tag does not match. Now, very similar to this, you can also use the last modified date, which again you can retrieve from the S3 metadata and use that to check these objects. Now, conditional reads are especially useful if you don't want to download the entire file or you just want to make sure that the file hasn't been modified or otherwise. You can use the conditional operations to achieve that. Hope this helps you to understand more about conditional operations in S3. If you like this video, please make sure to hit that like button. If you want to be notified of future such videos, please hit the subscribe button. Thank you and see you soon in the next video.